Hello, hello. I do not have a great connection here. Fortunate. Stream has started on YouTube though. Should be. I purchase it in a second. Okay. Still not up yet. Um. Okay, I am live on Twitch. Okay. Just it's showing up on my phone for some reason. Okay. There we go. Nothing. The thingy though. Where's the goddamn thingy, man? Yeah. Okay. I need to get to the mobile, like, dashboard stuff. I'll restart the app. I don't know, man. Oh, there we go. There we go. Alright. I've got it open now. All set up. Awesome. Alright, so I have a list for today. Gotta do some cleanup first, and then we're gonna get to the parser. Okay. There's a few things that we got a bit wrong. First things first, we need to remove all of the arithmetic equals, arithmetic assignment operators, plus equals, minus equals, that kind of thing. Because we don't actually have that in the language, so that mistake on my part. Whoopsies. So I'm gonna just remove this line here and then fix all the errors that come up. Should be a few. There we go. Okay, so just do that, right? Yeah. Okay. Awesome. Okay. Oh, whoops. And fix the slash one as well, 'cause that's here, if you remember. Just to remove that. Right? Yep. Very cool, very cool. What? Why is... Okay, I don't know, man. Oh, I see. Gotcha. I can just remove these, really. Yep. Okay, I'm gonna just copy this. Oh, actually, for this one, oh, I'm gonna leave. I'm not gonna leave that because that's the last one. Okay. So then, so the next thing we need to do is actually remove this way of scanning negative numbers. Instead, we're just gonna have minus will always emit just a minus token, and we're gonna handle like negative numbers with the minus sign in with our parser instead of dealing with it at the scanner level. That might be a little bit might be a little bit inefficient. Probably is actually, because like the string to integer conversion functions are like super optimized for specifically that task, so they're probably going to be better than something that I can make in the parser. But the thing is, if you remember from the last time we had the problem, we realized that there's a problem that if you like put this here, actually, there's a much better way to show you. Sample source 10 minus 21. Okay. Now, if we cargo run sample source.txt, look at this. Declare identifier colon integer identifier arrow literal 10. Wait, what? Oh, it's because I'm sorry. Okay. Oh my god. Oh, sorry. Just remove the minus equals and like that. Okay. Okay. So now, um, let's see. Declare identifier colon integer identifier arrow a literal 10 and then literal negative 21. Well, it should be literal 10 minus sign and then literal 21 because we're doing 10 minus 21. We can't. Like this is to the parser, it gets two integer tokens, right? Because we're making no distinction between unsigned and signed integers at the token type level, right? They both use the same token type. So that creates problems because then you can't do this. This is two integers and not a minus operation. So like you can't have this, you know. Yesterday I was just like, oh whatever, we'll just make some add spaces. Then I realized there's a much better solution here. I was assigning the grammar, and that is that we just oh god damn it. Okay. Never mind. Yeah. Which is just to make a minus sign, just emit a minus sign. Because like then what you can do okay, that's a bad idea. I'll explain here. Is make one type of expression that's like a integer and minus integer. That's a minus operation, and there's another type of operation that's minus and then integer, and that's basically making the integer to the right negative. It's basically the same as like 0 minus integer. There's nothing to the left. So yeah. Yep. Oh. Oh, actually, yeah. I think I messed up a little bit. Actually, never mind. No, I did not. Oh, good. Oh, good. Yeah. Um. Okay. So okay, that was next on the list. Okay. So that's done. That's done. Okay. Next, gotta go to token.rs, and what I'm gonna do is just move all of this into here. It was redundant to have a whole other enum store that stuff. Just store it directly. Right. Okay. Yeah, so I mean it's literally the same thing. Just a different like sort of structure, you know. So just do a bit of that. Remove a few. How many? Okay. Some more of that. And that. Very good. Actually. Ah, yeah, we don't need that anymore. Okay, boom. Yep, that's good. It's just much cleaner, you know. And look at this now. Like yeah, it's integer 10. You don't have the whole literal int 10 kind of thing. It's just dumb, and also like I'm pretty sure we're gonna have to like discriminate between like the types of literals at some point. So it's best to know that at the token type, have that at the token type level, and not have to like go another level down just to check whether what kind of literal it is. Like it was really just very redundant. It was like practically fucking stupid. Oh, whoops! I don't think I'm supposed to say that. Sorry. Kinda comes out sometimes. It's like if I put all of these in a separate enum, and then had like a value that's stored, a value of that enum. Like it's just stupid, right? So, so yeah, that's all good. What's next? There's just one more thing left. Oh, yep, got it. Okay. So what I realized with this programming language is that new lines are significant. We don't have semicolons, um, so there's no way to end a line except a new line. That's like the standard uh, like the standard way to do it. It's what's labeled as a best practice for like ending lines and stuff. So because like the specification is pseudocode still, so it kind of defines some best practices. That's why we have both Biref and ByValue. So you can be explicit when you want to with ByValue, and of course use Biref. But I mean, you can't be implicit with Biref. Implicitly, it's always ByValue. Or maybe sometimes it is, I don't know. Obviously, this interpreter is not going to deal with that. it is going to be implicitly by value at all times, but since it is pseudocode, in some specific situation, it might implicitly be Biref for some reason. I don't know. That's why it's like kind of defines best practice, and best practice here is to use new lines to end statements. And indentation is also significant for best practice. It really is just best practice that we're creating a language around. There's no like real concrete specification, really. As I said, it is pseudocode. It's not an actual coding language, but it is a somewhat standardized, like somewhat standardized system, and so would be helpful to like have a way to run code in it. Even if it's not like directly conducive. I don't think conducive is the right word here. I don't use that even. Not even if it's not directly conducive of the original intent and the language as a whole, or the original language as a whole. Anyways, so what that means is we're gonna have to record new lines. I would record indentations as well, but that's like way too much work, and like I don't care as much. Someone can edit if they like. Like just use the right type of indentation, man. We have like end procedure and stuff, so it's not gonna change. Like the indentation is not gonna change like the meaning of the code. So it really isn't like semantically significant, but for some reason they like in the spec say that you should always use this type of indentation, and you probably do have to in the exams, if you want the marks. Well, actually, no, you don't have to, because you could use a completely different system, completely different type of pseudocode, as long as you're consistent with it and it's like understandable. Oh god damn it, there's a cockroach on my wall. I hate this room, man. There's cockroaches everywhere. We had them in our old house, and everyone was so goddamn excited that when we're gonna move, no more cockroaches. Yay! But they came with us somehow, like lashed onto the furniture or some shit. Whatever. We need to add a new line token, and what we're gonna do is every time we get new lines, increment the line counter, and then instead of scanning a new token, scanning a new token, we just return this new line token. And so now we can get to the grammar. First we'll explain what this notation is. So basically, with grammar, what we want to do is like sort of create basically define how our sentences are made with these words that are the tokens. So like first we usually have like expression, and so how is an expression sentence made? It's like in English, actually no, you don't have different types of sentences. Never mind that. Well, it is like English, so like this whole sort of format and whole like, parser and scanner theory is based around like actual human languages and defining them, defining them like objectively. So how you do this is you have like an expression production. These are called productions. So um, an expression sentence is made by. Let's make a plus sentence first, like an addition sentence. Addition sentence is made with an int token, then a plus token, then another int token, or rather an expression token, a plus token, and expression token. This is a bit of recursion here. So basically, then expression is plus, or this bar is or. So expression is plus, or integer, or float, or char, or string, or identifier. These are basically literal types. It's this stuff. So literals, or a plus sentence. Right. So basically, then the expression is the top level. The top level production. What that means is basically we're gonna start with an expression, right? So say we write a program like 10 plus 6.7 plus negative 3.14 plus 6 plus negative 6. We don't have minuses right now, we only have additions, so we have to use negative numbers and add them. Okay, let's remove the negative numbers then, and I'll add, just keep the negative numbers, whatever, man. Okay. So how we would parse this is we would go to expression, right? The first goes to the first token. So this was our this is like just a bunch of characters. It goes to the scanner, and it is scanned into an integer token, plus token, float token, plus token, float token, plus int, right? So we start in the expression. That's the top level. That's where we start. So what do we have here? We have int, and if we go in here, there's int right here. Okay. Then we have plus. So we go in here, check all of these. None of them is plus. So we go into here. Oh, sorry. None of them has the plus, and none of them is the plus token. So then we go into this this production here. This is like recursion. Well, this isn't recursion. This is recursion, but like you can use these sentences within each other, right? So you go into here, your expression, and then plus, and then expression. You're like, okay, I have an expression, an int. I scan an expression, int, right? I have an expression. I have a plus. Do I have an expression after that? I have a float. Is that an expression? It is indeed an expression. So we have expression plus expression. So now we have, first we had an expression plus float plus float plus int, right? Now we have an addition, which is an expression, plus float plus int. So first this thing turned into an expression, that's like the int here. Then this thing, well, then this thing turned into an expression, but that's like sort of, this thing turns into an expression through the addition and through this stuff. It always goes back to back up to an expression because we want to be as generic as possible, so that we can have proper recursion. If we like recorded this as an int, well no, it's already an int. If you like recorded this as an addition, then you wouldn't be able to then like there's no production for addition plus expression. There's expression plus expression, so you have to store it as an expression. And additions can be expressions because it's inside the expression production, the expression sentence, right? So then you do the same thing again, expression plus float. You say float, that's an expression, and we have an addition, so expression, and the same thing, and it's just one expression. And so if any of you know Lisp, how we can then sort of represent this in the Lisp notation is top level we have an expression which contains an expression which contains an expression which contains an expression. One second. Okay, that is 4. Okay, so this expression is this one right here, and what it contains, it's an expression of type int, and it contains the number 10, right? And so then this expression, it contains this integer expression on the left, because it's a plus, so it has one expression to the left, one expression to the right. See, 2 expressions, stores 2 expressions. So this is an expression addition, and so it contains the int 10 to its left, and then it contains another expression to its right. This one is a float, and it is of value 6.7. Are you following along? Probably not. Sorry, I'm not explaining this well, am I? I think the basic idea here is it's a bunch of nested like expression values, and there are different types of expressions. They're all represented expressions, but they have their own type. This one only stores 1 value. Addition stores 2 values. That's all the expressions we have. So well, that's the idea. Okay. So this is OR. There's a few more symbols that we use. There is this thing that basically means that we could have this token, or we could not have this token, right? So it could either be expression plus expression, or expression plus and then nothing. And then there's the star. Star means there's some amount of this thing. There's 0 or more of this thing. There's 0 or more expressions here. It could be expression plus expression. Could be expression plus nothing. Could be expression plus expression. Expression. No. And then there's the plus. This means there's 1 or more. So it can be expression plus expression, or expression plus expression. But it can't be expression plus nothing, because it has to be 1 or more. And then there's grouping. So you can put this inside of parentheses if you want to. Makes it easier. So that's that. Okay. Okay. Start at the top, the simple stuff. So we use the way our grammar is defined to sort of make um, to sort of create our like precedence, operator precedence. So let's first start with expressions. There's also statements. They're kind of different, but not really. So start with expressions, right? So we sort of have all these sentences, like expression types, productions. Those are all terms that are practically the same thing, but not exactly. So don't confuse them too much. Um, and mm, and at the very bottom we have the primary stuff. That's our literals, uh, identifiers. This basically is could have any number of dot identifiers. Could be zero, could be more, right? So then you can have like x, or you could have x dot y, or you could have x dot y dot z, right? Could be any of those. You can't have x dot. You can't have x. Or you can't have x dot. That's just one identifier. You can't have x. Like you can't have just a dot at the end, right? You have to have an identifier after the dot. You can't have a dot before the first identifier. The first identifier in the sort of the list has to be uh, like a normal identifier. And it's probably better to have like a dot operator. Um, but I don't know. This is what I have right now. Whatever. Oh, actually, yeah, that is actually what's gonna happen later on, because we can't have left recursion. You'll see what I mean later. Um, oh man. Okay. Oh, and also we can't. This has to be an identifier then. Oof. Okay. I don't know. We'll do that later. Identifiers, more literals, true and false. We have grouping. It's like an expression inside parentheses. We have array indexing. I'll show you that in a second. Read, write, append, and random. These are also literals in pseudocode for file access. Array indexing, so that's identifier, the left bracket, and and then a potential expression comma, and then an expression right bracket. So what that means is you have to have an identifier first, so x, right? Then you have to have a left bracket. Then you have to have an expression in here. So this needs to be an integer, but we're not going to check that at the grammar level. We're going to check that like later on. It's like 3, and before that 3, you could potentially have an expression and then a comma. So you could have 2 comma, you could have 5 comma, or you could not have 5 comma, whatever. You know, you can't have one integer and then another. You have to have a comma there. But okay, let's actually have that in there, right? So we have an identifier, a bracket, a potential expression, and then a comma, and then a mandatory expression, and then a mandatory right bracket. See, it's array indexing. The 2 values, the comma is for 2D arrays. For some reason they do 2D arrays like this. Doesn't make sense to me. Let's do it like everyone else does normally, you know, like this. Like that makes significantly more sense, but apparently not to them, so whatever. Okay. That's the primary stuff. This stuff is at the very bottom, at the very top of the like the precedence, right? This needs to be evaluated first. So after primaries, primary stuff is our unary operators. Unary means there's just one operand. There's just one value that they store. Is that someone at the door? I'm not sure. I'm assuming it's not. Um, so for unary operators, we either have a not or a minus at the start, and then a unary. I think I need to put. Do I? Okay, no, I don't. Yeah, I definitely don't. Do I? No, I don't. Okay. So you have a not or a minus. Those are two unary operators, and after those you have a unary, right? And a unary is either this thing or it's a primary. So then you see what we're doing here is sort of creating recursion. So you could have a not something, a not, and then a primary, and then like a true, like if you wanted to, I don't know. So the recursion allows for that. And by saying that a unary is a unary operator, then another unary, or a primary, what you're doing there is making sure that the primary is always like further into the expression tree than the unary operators, because the primary will never be on top, right? It'll always be in this parameter of a unary expression. It will always be a parameter of a unary expression. It'll never be at the top. It will never have its own parameters. Well, most of these don't have parameters anyways, except the grouping. But we make sure that the groupings are still at the bottom. Like inside the grouping there are parameters, but like if you have a grouping in like a unary expression, the unary expression is not going to be a parameter of the grouping. If that makes sense. Does that make sense? So let's move to the move further up to more expressions. I think it'll make more sense when we do that. So here we have a unary, and then any number of operators, and then unaries, right? So that does, if you can, so that basically does is makes factor also unary. Just like unary can be just primary, factor can be just a unary, which can just be a primary, and so factor can just be a primary. Do you see what's going on here? We always start at the top here, at equality. This is the very lowest in the precedence, or highest, depending on which way you look at it. Basically just gets evaluated last. And we always start here. So either we have, so like usually you have like an expression like for greater than 6 not equal to false. This is stupid. You don't need a not equals there. This is like the definition of bad code. But just for example purposes. Okay. So like you start with the 4, right? And you always start with expression. So you go into equality, that's the only thing here. Go into logic, because you need that for the first thing. Go into comparison, go into term, go into factor, unary, primary, and then you're here. Or sorry, you go into factor, and then you check if is it a not or a minus. It's not. It's an int. So you go into primary. So now you have an int, right? Um, and it goes all the way back up. It's an expression, and it's an int, right? Oh, sorry, no, it is a primary still. Um, and so you have a greater than, right? So you go in here. Um, oh, right. Okay. So yeah, you're scanning an expression, right? So you have a primary, so then you go all the way back up. There's an int here. Okay, and then you check, is there, so next thing is a greater. Is that an equal or not equal? It is not either of those. So this star means 0 or more. In this case, it means 0. Okay, so there's an integer and 0 of those. You go down here into the logic, right? So now it's comparison and then this stuff comparison, okay? So the integer is here, basically. I think you go top from the bottom up, actually. Sorry. So you got an integer here, right? You go back up, place it here. Well, actually, no, you don't place that there. You just skip this, pretty much. This is like, what am I even trying to explain here? I'm trying to explain the fact that because this is all the way at the bottom, it'll always get evaluated first. Just due to the structure of our grammar, this will always get evaluated first. Or sorry, this will always be at the leaves of the tree, because it is at the bottom of our because of our grammar structure. If you didn't get that, you will in a second when we start actually coding this. I've taken way too much time on this crap. Sorry. I think I'll cut this out of the WOD so people don't get bored. We'll start to understand much better when we actually start coding this stuff. So I think first let's just make an expression parser. So first we need expression.rs, and I am going to quickly open a file. Open with text editor. Okay. Okay. Does that work? Why is that? What is that? Oh. There we go. Why? Ah. I see. Just a second. There we go. Okay. So we have a parser file. So expressions. Okay, so we need some data type to represent our expressions. And I actually have made some time ago, little script, little script, for can I paste here? Oh, God damn it. Jesus. Okay. There. We got it? We got it. Okay. A little script here. Right? And, oh, whoops. Okay. And, oh my god, what the hell is here? So many goddamn insects, man. Okay, so I have a little script here, and basically it just generates this whole file. Because there's a lot of redundancy here, so this like helps out with that. And so, um, 1 second. Okay, so it's okay if you don't know Python, and it's pretty simple. And we probably don't know Rust either, so like there's two libraries that you don't know. Because the rest isn't exactly mainstream. Well, it kind of is becoming mainstream. Anyways, it doesn't matter. So, okay, I actually don't remember what any of this code does. The path. What is path? Okay, define ASC out directory base name types. Oh, right, I got it. Okay. So I think if generate ASC output directory. Okay, let's try this. Oh my gosh. Oh my gosh. Holy crap. Hello. Wow. That is insane. Hello. Hello everyone, welcome to the stream. I'm just creating a compiler for a simple language. Have you considered writing your code generator in Rust? I could, but I don't know. Python seems simpler. I don't know. I could do that. It would take time though. I'll like try to figure it out off stream. See if it's any good. Good idea though. It is probably best to have like everything in the same language. Is it Python 3 or Python 5? No goddamn clue. I haven't used Python forever. It is Python 3. Okay. Very cool. Best advice for programming? Oh. I don't know, like what sort of sense? It's kind of a general question. Link deleted. Wait, what? True. You're right, yeah. Honestly, man. I don't know. How the hell do I use this? Oh, right, okay. I think I just go source. Let me just try this, see what happens. Okay. So, okay. Very cool. Is that it? Okay, yeah, okay. So I'm gonna ignore all this code because I have no goddamn clue how it works. And I will change this though. I'll rework it at some point to like sort of figure out what it actually does. So okay, what we have here, I'll first explain the code and then I'll look at the script. We just have an enum expression, and the enum contains like a bunch of different all the different productions. Um, so like we have expression equality, all that, right? So the one second. So we use this type for um, like being generic. You know, for this is what we pass around. As I said, we want to be as what do you call it? Be as abstract? No, generic. Be as generic as possible. There we go. Okay, so I think actually I'm gonna I'm not gonna change it right now because that's gonna take too much time. It's gonna be boring. But I'm gonna change it later. Uh, so this there's the binary type stores. It has to store it in a box. I don't know. It didn't work any other way, so probably inefficient. But sorry, I don't know how to do stuff. Not very smart. Um, so we have this right, left, and the operator, and right. So one second. So the operators for binary. Oh, right. So binaries in here. This is for an older. Well, it was obviously for an older project, but that type of project had binary expressions. So how we then generated that is like we give it a name, give it all the values that we wanted to have, and then done. Oh yeah. Well, actually haven't made this language. It's just a specification I got um, for if you know like IGCSEs, A levels, that kind of thing, like the exams, the like British exams, you know. So I'm like giving those. So they have a pseudocode specification. Well, you can write any kind of pseudocode because you know it's pseudocode. That's kind of the point. But they do give their own sort of structure that you can follow if you like. And most people, pretty much everyone, does do that. So I thought I'd create an interpreter for that. So, well, they didn't provide a grammar, but I did have to create the grammar myself. But they didn't have to create the language. Um, so yeah. Um, right. I guess we'll start with primaries then. Oh, right, we're doing it here. Primary. Okay. So what do you have in primaries? Okay, so we can have. Okay. How do I even? How? Oh, or do I? Oh, I think I actually. Never mind. I think this is just for parsing. I remember now. I remember now. And actually store as like binaries and primaries and binaries and stuff. Okay. Okay, I got it now. So then we need to have binaries. Gosh, I should have. I don't remember any of this. Okay. I'll add unary. Uh, okay, so that's just right. Unary is left. Okay. I guess binary just oh this, this, and that's unary. So how did you represent primaries? I forget. Well, I think I have to do grouping separately as well. So grouping and I just have a list of expressions. Okay, left parentheses expression. Oh, oh, it's just one expression, right? Sorry. Okay, so is it? Yeah. Done. And done literals. Okay, so let's see. Well, array indexing. I think I have to do that separately as well. But the rest can just be token, right? Just one token, literal, and then like value or something, and then done. Right? Okay, I'm gonna try that. Let's see if. Okay, that's pretty cool, right? So that script. All right. Mm, okay. And what was the other thing? Array indexing. Okay. Again, probably inefficient. Probably a better way to do this. But I cannot think of it, and so I will instinctively give up. Okay. Oh, array, okay. So I think I have to separately do 1D arrays and 2D arrays. Okay, what is an array index? You know what? I'm gonna just leave that for now. I'm gonna figure it out off stream and then we'll do that. Okay. That seems pretty good, I think, right? Yeah. Seems pretty awesome. Alright. Let me open up the page that I'm looking at. Okay. Got all this stuff. Oh man. Right, so now we have to write a visitor pattern. At least that's how most people do it, so that's how I'm gonna do it. Because I am a follower, not a leader. Okay. Just 1 second, I'm checking how I'm supposed to do this. Okay. Right. Okay. So in here, oh my god, I have to write Python code. I haven't wrote Python code in ages, man. Oh, I wish I'd already done this before. But alas, I did not. Okay. Let's start. Okay. Okay. So I write. I think I just write the visitors here. Oh, it's right here. Okay. Define. Do I? I don't need a separate function for this. So, interfaces is what I'm seeing here. Man. Okay.